where we're headed is we're going to fill in the breadboard with a transistor to control the pump. And I'll go through it step by step, but I'll also flash a diagram here that you will look at the end. Here, let me do that quick. And then at the end, you can look at the diagram after we kind of talk a little bit about what each component does, and you can just follow the diagram. And where we're headed is being able to control this motor using the microbit. Last time we met, we talked about how we could use the microbit as kind of a smart switch that we could program, and it would switch the LED on and off. And we'll need something to be turned on and off when we have the hand sanitizer. So why don't we just take this out, what we worked on last time, and instead of an LED, put the pump motor right directly into the microbit, and we can control it that way. It gets hot. So the LED takes a tiny bit of energy, doesn't make the microbit hot, but wires that are carrying a lot of energy get red hot. So if that happened inside the microbit, here's the microbit's main chip with all of the transistors in it. Those are so small and delicate that if they tried to carry an energy for the motor to do work, then they would get too hot and this microbit would start to smoke and it would stop working. So we want to protect our microbit from getting fried out. And so instead of using the microbit itself as a switch for the motor, we're going to use the transistor, one transistor, as a switch. Instead of all the transistors packed into here, maybe 100,000 transistors in all. But this is just one, and look how big and heavy duty it is compared to that. And when you look at a transistor, it's got a flat side, and you want to put that toward you. Always have that toward you, because then you can keep track of which leg is which. So we're going to put it on these 3 rows, and we're just going to pick those because they're not connected to this part of the breadboard, but they are connected to these 4 other holes in this row. So this leg is connected to these 4 holes, this leg is connected to these 4, and so on. So that's going to be a great switch, and we're not even going to use the power that comes from here. Remember, that power comes out in 3 volts from the microbit, and we want more like 5 volts. And 5 volts comes out of our USB with the leads on it. So this is not a normal USB. This is one where this has one end, and the other end are positive and negative, and it happens to be 5 volts. So we'll stick those into the rail. So the red goes next to the positive. The red goes next to the positive with the red, and the black goes next to the negative with the blue. Black is blue on this. Aha! And then we'll plug it into one of the other USB ports on our computer, or the little gadget that plugs into the wall, like one of these ones. Plug it in to a electric outlet. So now we've got power to our breadboard in the bottom here, and we're going to use the transistor like a switch. So we're going to connect the positive of the pump right here to the positive rail, so that we'll get power to the pump, except it's not connected to negative, so nothing's happening, because power has to go in a loop. We're going to use the transistor as a switch. So it's going to go, we're going to use the transistor as a switch. It's going to go on the right leg here, and it's going to go, and then the left leg, the leftmost leg, ignore the middle leg for now, that is the ground. That is going to go back to the negative over here. So what that does is it acts as a switch. So electricity comes from here, goes through the motor, it goes through the transistor, and then back to negative. But the transistor only turns the switch on when the microbit tells it to. So now we're going to connect the microbit to the transistor. And so we're going to have our signal, like we can use the same code that we used for the LED. So we'll stick it into the pin that we chose, maybe pin 2, and then for on and off, and then we'll put the signal into the signal's really just like speaking a language. It's not, it's a type of electricity that is carrying information, and that information goes in the middle leg, and it just tells the transistor to go on or off. We'll stick that signal in the middle leg, and the only thing left to do is to make sure the ground from your microbit is connected to this ground over here. Okay, as a last note, try to get that together, and as always, just send me an email if you have questions. But the other thing is, if you feel like going ahead, and now we've got this great output where we can output a signal to the motor and have the motor go on. And last week we talked about an input where we had a sensor that could take in information. So if you want to try to connect everything together, you would have a way to automate a hand sanitizer based on what the sensor sees.